Good afternoon. In this presentation, we will explore the concept of hash function, particularly their significance in the field of cybersecurity. We will cover the hash functions, or how they operate, their applications, and the best practice for use. Discuss several key topics. First, we'll define what hash functions are, followed by their purpose in cybersecurity. Next, we will look at different types of hash functions, their operational mechanisms, uses in the industry. Finally, we will consider the limitations and best practices for implementation. A hash function is a hash function is a mathematical algorithm that transfers an input or message into a fixed size string byte. The output is typically a digest that is unique to each unique input. Understanding the concept is crucial for appropriating its role in cybersecurity. Hash functions serve several purposes in cybersecurity, including data integrity, verification of password, storage, and digital signatures. By ensuring that data has not been altered, hash function enhance security across various applications. And basically, what that is talking about in reference to various applications, once that information has been hashed, you have to have the appropriate key or the appropriate equipment to unhash or to open that particular file to get the actual information out of the file. And that can vary. And, after serving so many years in the military, we had to have an encryption key and a decryption key in order to open certain things that were sent to us, or certain things that we had to send to an ally or another component of my branch, or whatever the case may be. You have to have something that will allow you to decrypt something in order to read the information, or vice versa. There are several types of hash, including MD5, SHA-1, and SHA-256. Each has a different characteristic and application, with SHA-256 being widely used for its security features, particularly in blockchain technology. And I'm sure some of my audience here have heard of these three different hashing mechanisms. So just keep in mind, SHA-256 is the favorite one to be used and during concurrent time frame. Hash function process data through a series of mathematical operations resulting in a hash value. Even a small change input will produce a significantly different output, making the hash function effective data integrity check. And basically, what that means, depending on how you're encrypting or hashing a certain information that you're sending out, if you change one character of the original data, it's going to cause a totally different output. And as we move along, you'll understand exactly what I'm referring to as we move forward. Hash function takes an input and applies a deterministic algorithm to produce a fixed size output. The process is fast, is irreversible, and unique, ensuring that the original input cannot be retrieved from the hash value. And what that means is just once that information has been hashed, you can actually access the original information that's currently being hashed. If that makes sense to you. Hash functions are used in various aspects of cybersecurity, including secure password storage, verify file integrity, and supporting blockchain technology. Their ability to create a unique identifier makes them invaluable. Despite their usefulness, hash functions are not foolproof. Vulnerabilities such as collision attacks, where two different inputs produce the same hash output, can undermine their effectiveness, and awareness of these limitations is vital. Okay, something simple as a collision where two different inputs produce the same hash. Depending on where that information is going to, it could be very uh, bad for the audience that's receiving that information. For an example, like when I was serving in the military, if I was sending a no movement order and sending another order for hot time is 1500. Okay. If you were the person that was supposed to receive the no movement order, you definitely wouldn't want to receive the hot time order because the no movement order supersedes the hot time order. And the hot time order just means that you're allowed to execute whatever task is before you. The no movement order is no movement. You don't execute anything. So, that's just an example. But when you have that collision, which order goes where? Because they both produce the same output. And there are other items out there in play that will ensure that you don't have collisions. And you can also verify the information prior to sending that information out. Best practices. To maximize effectiveness of the hash function, it is important to use strong algorithms, keep them updated, and combine them with other security measures such as salting, stretching, enhanced password security. And what that all actually means is let's keep your algorithms updated because technology is changing every day. Uh, and you take other security measures that are out there in place and you combine those, like I mentioned, salting, stretching. And salting is nothing more than adding something different to that particular algorithm to sway others to think it's something else. And stretching is adding an additional character to that password and to enhance all the security. And it's done almost on a day-to-day basis, and especially within the military. In conclusion, hash function plays a crucial role in cybersecurity by understanding their functionality, and application, along with their limitation and best practice. We can better protect our digital assets. And believe it or not, this really works. I've used it for over 25 years after serving in the military, and it works great. I hope you enjoyed this presentation. Have a great day.